let's look at how we can classify some three-dimensional figures now. Okay, given the vocabulary that we just learned, let's just kind of sort through some and see what we can do. All right, so this one asks us to classify the figure and then name the vertices, edges, and bases. Okay, now I'm going to make one assumption with this picture. I'm just going to assume this. Okay, I'm going to assume that all of these side lengths are actually the same. Okay, and so I will just maybe start by classifying this, right? So let's just maybe look at the bases here, right? So this base that we see right now, that's on the bottom, okay, it looks to be parallel with this base that we have on the top, okay. They are actually, this is connected by parallelograms, right? So there's one parallelogram. Here's the second parallelogram that connects the faces, right? Here's another parallelogram that connects the faces. And then I guess our last parallelogram that would connect the two faces would be right here, okay? And so really, we might look at this right away and say, well, this is a rectangular prism, right? Because the base is a rectangle and it has, two faces that are opposite of each other and are connected by parallelograms. And but since all the side lengths are the same, we can actually classify this as a cube. Okay. So again, this is that one case where all of the sides are really congruent. Okay. And so this is actually going to be considered a cube. Now let's look at the vertices here. Okay. So all the different vertices. Okay. Now remember, the vertices are going to be where basically these three different faces meet to form a corner. Well, it's just the corners of your figure, right? So I guess our vertices would be A, B, C, D, and then E, F, G, and H. Okay. Let's look at some edges now, right? So there are going to be lots of edges as well. Okay, so the edges are actually segments now, remember, right? So it actually might be smart to, I'm going to do a little bit of erasing here now, just so this is a little bit more clear, right? So our edges, let's just maybe mark them as we count them. So we could call this CD would be one of our edges. CB would be another edge. BA would be an edge. And AD is another edge. Okay, let's continue. I could call FE an edge. Okay, I could call FG an edge. We call GH. I'll just call it HG. Okay, is an edge, and then HE is another edge. Okay, there's more. I could call CG an edge. I could call DH an edge. AE and BF are also edges. Okay, and now it asks us for the bases, right? Well, there could actually be 6 bases this time, if the bases opposite of each other are congruent. Okay, but let's just write down what our bases would be, right? So bases, again, there would be 4 actually in this case, or actually, sorry, 6. There would be 6 bases in this case. So one of them could maybe be this one right here. Okay, so I could call this CDHG. Could be one of our bases. Okay, maybe I'll look at this one next. I'll call this one ADHE. Okay. Another one could be right here. I'll call this one ABFE. Okay, and the last one, maybe we'll go with kind of the face on the back here. Okay, so this last one here would be maybe FGCB. Okay, and now I just have to look at the top and the bottom, right? So the top, I'll maybe just kind of outline another color here. I have to kind of do this one now, yeah? So it's going to be FEHG. And the very last base that we really could consider here would maybe be ABCD. All right. So that's the first example we're going to look at. In the next video, we'll go through a few more examples. I encourage you to watch them and take notes on them because it's going to be a little bit more difficult than just a cube.